I'm Natalie.
I'm Cam.
And I'm Jillian. What's an HPLC, you ask? Well, it's a high-performance liquid chromatography, an analytical instrument used to separate and identify the components of a liquid sample. It is able to reveal many important things, like the relative concentrations of the analytes used in the sample, as well as their identity via retention times. Analytes are usually analyzed in the micromolar range.
First, let's talk about the setup of the instrument. On top is the solvent cabinet. This is where the 4 solvents of different polarities are stored. The 4 solvents used in this lab are water, methanol, acetonitrile, and isopropyl alcohol. Depending on the relative polarity of your analyte, you must choose a solvent combination that can push the sample off the column in its separate components. Choosing a solvent with similar polarity to the polarity to the analyte allows the sample to spend more time in the mobile phase and move off the column faster. As you can see here, the solvents have tubes which connect them to the degasser.
The purpose of the degasser is to ensure that no air bubbles enter the column. The presence of air bubbles can lead to a buildup of pressure that can damage your column. Flick the tubes like this to move air bubbles down into the degasser.
Sitting directly below the degasser is the quaternary pump. This is where any of the 4 solvents can be mixed in any combination. You can even use all 4 solvents at once. You wish the LCMS could do that.
At the base of the instrument is the UV detector. Normally, it is set to detect at a fixed wavelength. However, it can be adjusted depending on what wavelength of light your analyte absorbs. Started it.
To the left of the instrument is the waste container. If you find this container to be more than 3/4 filled with waste, contact Bill to get a clean container. This knob allows you to control whether or not the solvent is sent to the column or to the waste.
This is the injector. Unlike many instruments you may be familiar with, the HPLC requires manual sample injection. On the back side of the injector is the sample loop. This specific loop holds 10 microliters. When the loop is overfilled, the overflow goes into these tubes and then into this waste. There are 2 positions on the injector, load and inject. We will talk about how to load the sample later.
Okay, so stop the video. Now we will demonstrate how to use the software for the HPLC. First, we're going to turn on the computer, which can be the hardest step.
There are 2 programs on the computer to pay attention to, LC Online and LC Offline. The online program is for instrument operation, while the offline program is for analyzing data.
First, let's open the LC Online program. Click the Run Control tab in the upper left corner to choose a file path to save your data under. First, go to Sample Info, and in here you can see a counter number and a path that your data will be saved under. For example, we have been saving under chem32/data with the subdirectory 9-30-19, which is the date, and the prefix peptides. Each run will be automatically saved under this file path, and the counter number will appear after the prefix to designate each new run.
To begin the analysis of our analyte, we must first look at the cartoon of the HPLC setup shown here on the screen. The image is made up of the following components: the solvents, the column, the UV, and data analysis. Using these, you can change the settings of the instrument. One thing to note is that the column cannot be changed using the software. Before experimentation, a specific column must be selected for the analysis of the samples. This lab currently uses a C18 column and reverse phase chromatography, which is useful for analysis of many samples that are nonpolar or mildly polar. Picking the right column depends on the polarity of the specific analytes as well as the solvents in use.
Just go. Okay. We've obtained the correct column for our purposes, so we can continue prepping the instrument. First, we need to turn on the pump. To do this, you left-click on the first image, click Control, and then click On. Then we need to set any gradients for the sample run. To do this, you left click again on the first image, click Setup Pump, and then you can alter runs, times, and solvents as necessary. Using a gradient is very useful in effectively separating components of the sample. This is done by varying the polarity of the mobile phase over the course of the run. This allows the samples to come off of the column at different times, thus improving separation.
To set your preferences, left click on this image and click Turn On to power up the UV Viz. From these control settings, you can also set up the signal to control and change the wavelength at which you choose to analyze your analyte. Samples are typically analyzed at 214 nanometers, as this is an optimal wavelength to absorb at for many compounds. However, this can be altered as needed, depending on what wavelength is best for your sample.
When changing your current method, go to the top left of the screen and click on Methods tab. From the drop-down bar, select Save as New Method to ensure your new parameters are properly saved in the instrument database. Make sure to run your priority solvent through the column for a few minutes to equilibrate it before injecting your sample.
After successfully powering up each part of the HPLC and creating and saving your method, it's time to inject your sample. To do so, first make sure that this black knob is set to load and not to inject. Rinse the needle 3 times with DI water, like so. Then fill the syringe with 40 microliters of your sample, no sample needed. Insert the needle in the slot and ensure that it's pushed all the way to the end, pushing past that first stop point. Then proceed to inject the sample into the sample loop. Take care in this process, as failure to inject properly may cause leakage and decrease the lifetime of the injector. Once finished, fully remove the needle from the slot before switching the knob from load to inject. This completes the sample injection process, and the HPLC will automatically start running the sample and collecting your data.
After your sample is finished running, the completed spectra is displayed on the computer screen. This spectra includes a list of peak retention times and areas which are unique to your sample. To analyze the spectra, open the LC offline program. This program allows you to manually integrate your peaks to get a more accurate measurement of the data. To do this, click on the Manual Integration button, shown here, and draw a new baseline which aligns better than the automatically produced integration. Once completed, make sure to record all peak retention times and areas, as these values are crucial for determining what components are in the sample.
Once the data has been analyzed properly, it is important to record the file path that your data is saved under. Remember that the HPLC automatically assigns a new counter number to each run. Therefore, it is crucial to know which sample run is associated with what counter number.
Once you are done running your samples via the HPLC, make sure that the instrument is properly turned off. First, you must exit the software. This is awkward. Next, you can simply click these buttons on the left side of the instrument to turn off each component of the machine. The end.